Finding the inverse of a square 2 by 2 matrix is one of the few skills in matrices that you need to be able to do by hand as well as with a calculator. So to do that, first step in that process is to find what we call the determinant. And to find that determinant, which is just a number, we need to perform the calculation A times D subtract B times C. And A and D and B and C simply refer to a position within that 2 by 2 matrix. So for example, B refers to the top right hand element, C refers to the bottom left hand element, and so on. So once we've figured out what those elements are, we multiply A times D and we subtract B times C, and that gives us a number which we call the determinant. So once we know the determinant, to get the inverse of that square matrix, I simply put 1 over the determinant outside a square matrix. And you'll notice within that square matrix, A and D have now swapped positions, and B and C stay where they are, but they've changed signs. So it makes it a little bit easier if we try one with actual numbers in there rather than that general form of the formula. So in a specific example, we're given matrix M, 6, 2, negative 3, 2, and we want to first of all calculate the determinant of matrix M, and then if we can find the determinant, we need to calculate the inverse of matrix M. So if we're looking, in this case, A is 6, B is 2, C is negative 3, and D is 2. So if we're calculating the determinant of M, we are calculating A times D and subtracting B times C. So when I calculate that, 12 take away negative 6, or 12 plus 6, is 18. So the determinant of this matrix is 18. So once I know what the determinant is, I can then calculate the inverse. So using the formula from my first page, 1 over the determinant, and then within my 2 by 2 matrix, my A and D elements swap positions, and my B and C elements stay where they are, but they change signs. So that is the correct answer. I can simplify though, because I can see in 18 and 2 and 6 and 3, they can all cancel. So if I was to take the 1/18th into that matrix, I can cancel that down and make that, instead of 2/18ths, it would be 1/9. Instead of negative 2/18ths, it would be negative 1/9. Instead of 3/18ths, it would be 1/6. And instead of 6/18ths, it would be 1/3 in simplified form. So you do need to be able to recognise the difference between a non-simplified and a simplified answer, particularly in the case of maybe a multiple choice question where your paper answer looks like this, but your calculator answer or the exam answer options that you're choosing from might look like this, and being able to recognise that they're the same thing is an important skill. Your calculator will also calculate a determinant and an inverse. So on your calculator, if you're doing this calculation, if you go into the menu and go into your matrix and vector menu, you'll see there is a determinant option. You hit that option. I do need, because I haven't stored this matrix already as matrix M, I do need to enter the matrix. So 6, 2, negative 3, and 2. And hit enter, and it does the calculation for me. If I already had that matrix stored as matrix M, I could just do menu, matrices, determinant, M, enter. Okay. If I keep going, and a new matrix, matrix P, find the determinant of matrix P, and hence find inverse of P if it exists. So again, A times D, 4 times 3, subtract B times C. So if I'm calculating that out, 12 take away 10, my determinant is 2 this time. Therefore, if I'm doing my inverse now, 1 over the determinant, and then inside the bracket, A and D swap places, B and C stay where they are but swap signs. Okay, and again, important to recognise, if I'm simplifying, I'm quite happy leaving the fraction out there, but you might be doing a multiple choice type question and the answers in the options might look different. You might see something like 3 over 2, 5 over 2, 2 divided by 2 is 1, and 4 divided by 2 is 2. So you, again, need to be able to recognise that these two matrices are the same. So if you're doing that on the calculator, again, menu, matrix and vector, determinant. And I'm typing in the matrix again because I haven't stored this one either. 4, negative 5, negative 2, and 3. So it's nice to be able to check my answers that they're correct. Again, if you wanted to put in the matrix and find the inverse as well, the calculator obviously will do that. So you need to type in the matrix to the power of negative 1 and you'll see that same answer. One final one to have a look at. If we are working out something like the determinant for matrix Z. So if I'm calculating determinant of Z and I'm calculating A times D and I'm subtracting B times C, in this case 4 times 6 is 24, 8 times 3 is also 24, and this time I get a determinant of 0. So this means that this matrix is called a singular matrix. Okay, so Z is a singular matrix, and singular matrices do not have an inverse. So very important word to remember, singular matrix simply means it is a matrix with a determinant of 0, and because it has a determinant of 0, it means the inverse does not exist. Okay, and that is because if I'm trying to use that rule, 1 over the determinant is 0, 1 over 0, and that is an undefined fraction. So keep that in mind, undefined, singular matrix, no inverse exists. So we often see questions using that terminology, that singular matrix terminology, and it says to us if matrix A is a singular matrix. So I'm assuming if you got a question like that, that you understand that singular matrix means this matrix has a determinant of 0, find the value of M. So if you know the determinant is 0 and you know the calculation for determinant is A times D multiplied by B times C, so you know that information, we can use our values in the matrix A to calculate the unknown value M. So in this case, A times D is 2M minus B times C, negative 3 times 6, and I know that equation is equal to 0. So if I wanted to use the calculator straight from there, I can do it straight from there. Menu, algebra, solve, 2M, take away, minus 3 times 6 is equal to 0, and I want to solve that equation for M. It tells me M is equal to negative 9. So in that case, if this matrix was 2, negative 3, 6, 9, you can check that that is a singular matrix, and that matrix would then, as a result, have no inverse.